Hey, this is Math 6, Unit 4, Lesson 13, Rectangles with Fractional Side Lengths. So first of all, we have some squares here, and we're looking just real quick at some areas of squares, and we can see this one, we have a 1 inch by 1 inch square in our first one. We have a ½ inch by ½ inch in the second, and then a 2 inch by 2 inch here in the third one. The first question says, what do you notice about the areas of the squares? And write down your observations. Okay, so in terms of area, when we're talking about area, we're talking about the space that is inside of the square, right? And so in the case of the inch, we can see that it's, well, 1 inch long, but when I compare it to this ½ inch, one of the things I notice is that the ½ inch is obviously smaller, but inside this ½ of an inch, I could actually fit 4 of those inside of that one, can't I? Right? And so when I think about area, area is going to be the length times the width. This area has an area of 1 inch squared because 1 times 1 is 1. What happens over here to this one? We end up with a half times a half, which equals 1/4 inches squared. Now that might be a surprise to some of you guys, but what's interesting is how that number relates to what do you see happening right here? Well, if this is 1/4 of an inch squared, what do we see here? I see that I have 1 square inch, right? But inside that I have 1, 2, 3, 4 of them. This piece appears to be 1 out of the 4 that fit right there, isn't it? See, kind of interesting, isn't it? So we can see how they're related just based on tiles. When I look at this one, I have a 2 by 2, so what do you think is going to happen here? When I multiply 2 by 2, I end up with an area of 4 inches squared. Well, 4 inches squared is going to be related to which one of these squares? This one or this one? I'd go with this one, right? Let's chop this up into inch segments, like so. And we end up with 1, 2, 3, 4 square inches. We have 4 of these things right here. So this idea of it being 4 square inches is related to, well, what is our kind of original size? 1 inch by 1 inch. That's what we're working with. That is an inch. Everything else is related to that one size here. This one is 1/4 of that whole one, and this one is 4 times that one right there. Right? So kind of some interesting observations here, but just looking at multiplying whole numbers and fractions again. So when we look at the next question, it says, consider the statement. A square with side lengths of 1/3 inch has an area of 1/3 square inch. Do you agree or disagree? Well, up here, when we had a square with side lengths of 1/2 of an inch, did it have an area of a ½ of an inch? No, it had an area of 1/4 of an inch. So what happens if we take the side lengths of 1/3 and we multiply them together to find the area? Will we get 1/3 as the area? Well, the reality is we end up with 1/9. So how is that happening? Well, let's take a look here. What we're thinking is if this is the size of 1/3 of an inch, and I take that and I put it inside of my 1 inch square, we're saying that if I take the square and divide it into thirds here and thirds here, how many of these can I fit inside of there? I can actually end up with 9, can't I? 1, 2, 3, 4, 5, 6, 7, 8, 9. And so the area of just one of them is 1 out of the 9 that it would take to make the whole big 1 by 1 square inch. All right? Cool. Let's move on to the next activity. The next one here is called areas of squares and rectangles. All right. It says use 1 piece of 1/4 inch graph paper for the following. Use a ruler to draw a square with a side length of 1 inch on the graph paper. Inside the square, draw a square with a side length of 1/4 of an inch. Okay, so let's take a look at this. If I use a piece of graph paper like this one, let's Let's use a different color than blue since we have blue lines. So we're going to draw one that's a 1 inch long. So that's going to be quarter, half, 3/4 a whole. Quarter, half, 3/4 a whole. So it says to draw a 1 inch square on the graph paper. And then inside of that, we're going to draw a 1/4 inch square. Something like that. Now, if you don't have a graph paper, that's okay. I didn't have it my first time, so I just drew my own little square and chopped it up into fourths. That's fine too. So the first question says, how many squares with a side length of a 1/4 inch can fit in a square a side length of 1? So basically, how many of these green ones can we get inside of here? Well, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We would say 16. Or we notice it's 4 times 4, which is 16. So we can see that we can get 16 inside of there. But what is the area of a square with a side length of 1/4 of an inch? So the question is, what is the area of this green going to be? Well, the area again is 1/4 times 1/4, the length times the length, length times the width, sorry. But we also can know that because there are 16 in here, the area of one of these things would be 1 out of the 16. Well, does that work out? What's 1 times 1? It's 1, and 4 times 4 is 16. So that would certainly work, because what we're saying is that inside this square, there are 16 little squares. Let's look at the next one. Use a ruler to draw a rectangle that is 3.5 inches by 2 1/4 inches on the graph paper, and write a division expression for each question and answer the question. Alright, so we're going to draw one that's 3.5 by 2.5. Alright, so 3.5 means I have to think about this real quick, because I'm going to use 3 times 4 equals 12, so I have to go out at least 12 plus a half is 2 more. You need to go out 14 squares here. This is 2 times 4, which is 8, and another one for the fourth, so I'm going to go 9. So I got to go 14 by 9. So let's do this here. We'll start here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 that way. And going down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and we'll come back around this way. And we'll drop back down that way. Alright, so this is my 3.5 by 2 1/4. Let's go ahead and make my inch marks real quick, just to help us see what's happening. 1, 2, 3, 4. So this is an inch that way. 1, 2, 3, 4. We have an inch this way. And we have an inch this way. And for the 2, we're 1, 2, 3, 4. 1, 2, 3, 4. Alright, so we're talking about area still, right? Looking at this shape. So we drew the rectangle that's 3.5 by 2 1/4. So this is my 3.5 on this side. This is my 2 1/4 on this side over here. And it wants to know how many 1/4 inch segments are in a length of 3.5. So how many of these green guys right here would be on a length going this way? We'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We would say we have 14 right there. That's easy enough. Of course, we figured that out before. Now the reason how we figured that out, let's back it up real quick. Why did we say 4? Well, we said if the paper is 1/4 inch, that means it takes 4 of them to equal 1 inch. We knew we had to get to 3 inches for the first part, so we multiplied by 3 to get me to 12. Okay, and then we still had 1/2 inch. Well, 1/2 inch is 1/4 plus 1/4 is 2/8, which is 1/2, so we had to add 2 more, which gave us 14. We did the same thing for the other part as well, for the height as well. Okay, how many quarter-inch segments are there in 2 1/4. All right, so how many are going to be going down this way? If we've already done this again, we're going to look, we can count them and go up and go 1, 2, 3, 4, 5, 6, 7, 8, 9. And we can say there's going to be 9 there. And again, the way we figured that before is we said, well, if I have 2, right, I know that 1/4, I need 4 of those to make 1 inch. I already have 2 inches, so 4 times 2 is 8. And then I have 1 extra 1/4, so we added 1 more to make 9. That's how we did that to figure out what size our rectangle was going to be to begin with. Okay, so now we've done that, and that's what we got so far. Let's look at number 3. Number 3 then says, use your drawing to show that a rectangle that is 3.5 inches by 2 1/4 inches has an area of 7 7/8 square inches. Okay, so we have to use this rectangle to prove that this area is 7 by 7/8. Okay, square inches. Now a square inch is going to be this shape right here. Let's go ahead and color this one whole block in real quick. This is a square inch. Okay. And we can see we have 1 there. Here's 2. Here's 3. That's not 1 quite yet. Here's 4. Here's 5. And here's 6. Right? So we know we have those there. We have 6 already. So we can see how 7's probably going to be about right. But I don't see all 7 quite yet. When I look over here, though, I notice that I have this segment here, which is a 2 by 4. And then I have this one, which is also a 2 by 4, which means if I was to think about moving this one, if I move this one over here, what would I have? If I move that one right there, I would have another square. So that becomes number 7. Okay, how are we doing so far? Are we okay with that? So that's 7. And then I have these guys left right there. Well, how much is that going to be? That one's going to be a little bit different, isn't it? Okay. I can see already that I have, I'll get a different color out. Oh, I've already used pink. I'm going to go to blue. If I look at this, I have a 1/4. Alright. I have 4 there. I have 4 there. If I had another 4, I'd have a whole one, right? But I don't quite have that. I have just part of it. I would need 2 more to make that actually a whole thing. So what I end up having is I have 1, 2, 3 of these kind of strips like this. So 1, 2, 3, the strips of 4. Am I on the paper still? Good. All right. And then 3 of them. So I'm looking like this so far. I have this. I also have these 2 right here. And what I don't have is that. So I don't have a whole 8, do I? But it's definitely close. I can see how you might think 7/8, but let's see how many I do have. What do I have? I have 4, 8, 12, 13, 14. I have 14 out of a total in the square is 16. And I can reduce that down to 7/8. So how many do I have all together? If this is a 7/8, I have 7 and 7/8. 1, 2, 3, 4, 5, 6. This orange one together becomes 7. And the blue left over becomes a 7/8. Alright, so pretty cool. Let's take a look at how that works here. Right, that's the drawing to show that that's the way that that is going to work. Okay, so in terms of the math of it, we could think of it like this. Right, we have a, we can think of this as being a 3 by 2. Right, that first part here is a 3 by 2. I really have a, I can draw this out again. I have this 3 by 2 section, which is the 6, right? Now over here, I had the half section by 2. This is the half times a 2, and so 1/2 times 2 is equal to 1. So there's my 1. Right here, I have a 3 times a 1/4. Well, what is 3 times 1/4? 3 times 1/4 equals, in our case here, is it a 4th there? Yeah. 3 times a 4th is 3/4. 3 times a 4th is 3 4 1/4. 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 3 times a 4th is And what's left right there is a half times a fourth, which is 1/8. So I have a 6, I have a 1, and I have 3/4 plus 1/8. Well, 3/4 plus 1/8 need to have a common denominator. So I'm going to go with an 8. To go from 4 to 8, I need to multiply by 2. So 6 times 2 is, or 3 times 2 is 6. Now I can add 6/8 and 1/8, which equals 7/8. Okay, so I have my 7/8 over there, and that's what I'm left with here. So this part is a 7/8. And so we can see how that works out there with just the math part. So both the picture and the drawing part work out the same. All right, let's take a look at the next one. All right, here we go. Areas of rectangles. It says that each of the following multiplication expressions represents the area of a rectangle. We have 2 times 4, 2.5 times 4, 2 times 4 and 3/4, 2.5 times 4 and 3/4. All right, so the shaded area is all the same. So which one matches which one? All right, well, first of all, I notice that they all have a 2 and a 4 in them, and then they tend to grow a little bit by the 2, or they grow a little bit more on the 4, or both of them all together. So I'm going to say that safely this is going to be my 2 by my 4. This is C right there. Okay, that's probably a good option there. So if this is my shorter side, 2, I notice that in this one I go 2.5 times 4, so the blue length line, this stays the same, but I add a little more. This looks like it's my 2, and there's my half, and this is the 4. So that's going to go D right there. This one, I'm going to keep the width across the same. That's still 2, but I took the 4 and I added to it this 3/4 part right there. So that looks like A. And then looking at this next one here, I do them all together. There's my 2, there's the 4, and this is the half section, and here is the 3/4 section right there. So using the diagram that matches 2.5 times 4 and 3/4 to show that the value of that is 11 and 7/8. 11 and 7/8. Okay, we can do that. So first of all, what we're doing is we're saying we have lots of little pieces, right? We know that 2 times 4 is going to be 8. So we know when we take a look at this here, 2 times 4, this blue section has a value of 8. That one's pretty straightforward. Okay? But let's look at the other ones. This section right here is what? It's a half times the height here, which is 4, and a half times 4 is 4 over 1 is 4 over 2, which reduces to 2. So we know we have 2. We have 8 so far, and there's 2 inside of that little space right there. Down over here, in this space, it's a 3/4 by the length, which is 2. We're just multiplying. So that becomes 6 over 4, which is 1.5 right there in that space. And then what's left for us is that little space. Well, the little space has a length of, or a width of a half and a height of 3/4. So we'll multiply those together and we have 3/8 is what we have. So we know we have 8, 9, 10, 11, and then we have to put those things together. Okay, we have to add 3/8 and a half. So 3/8 plus 1/2. I need a common denominator, so I'm going to go with the 8 because 2 times 4 is 8, so 1 times 4 is 4. So now I can add this up, so I have 3/8 plus 4/8, which is 7/8. So I know that that's going to be 7/8 there. So in taking the half and the 3/8 together, those things together make 7/8. So I end up with 8 plus 2 plus the 1 plus 7/8, and that becomes 11 and 7/8. Whoops, I went off the page. Sorry about that. I'm working in a new spot today, so I can't quite see what I'm doing. All right, cool. And that's it for that one. All right, let's see. The next activity is an Are You Ready for More? It's interesting. You certainly could do that one. I'm going to skip it today. because today I am not ready for more. I could, but we have more to do on other things today. So let's move to part 4. How many would it take? Part 2. It says Noah would like to cover a rectangular tray with rectangular tiles. The tray has a width of 11 1/4 inches and an area of 50 5/8 square inches. So we know it has a width and it has an area of that. We have to find the length. All right, that's not too bad. Why isn't it too bad? Well, we know that to find the area, that our area is usually our length times our width. And in this case here, they told us that our area was 50 5/8, and they gave us no length. We don't have a length, so let's just call it L. And they gave us a width of 11 1/4. Well, so we've done this same problem before, haven't we? We've been doing them the last several weeks. So the L is just like our question mark, so we can turn this multiplication equation into a division equation. And to do that, we end up doing what? We end up saying that we have 50 5/8 divided by that number right there, 11 1/4. And now we can solve this equation here for what L is going to be. All right, so to do this, we have some crazy numbers. So 8 times 50 is 400, plus 5 is 405 over 8. And that's divided by this one, which is 4 times 11 is 44, plus one more is 45 over 4. Now, to do division, we multiply by the reciprocal. So that's 405 over 8 times 4 over 45. And we can see that some numbers are probably going to be nice to work with, right? So there's 1 4 in here, and there's 2 4s in there. And when it comes to the 45s and this guy here, the first thing I did is I said, well, at least I know that 5 goes into here 9 times, and 5 goes into here 81 times. So I knew 5 went into both of them. That's what I just knew first of all. And you just calculate, you can figure that out. Then I had 9 and 81 left. Can I keep reducing? Sure. I know 9 goes in here 1 time, and 9 goes in here 9 times. So now, when I multiply across, 9 times 1 is 9, and 2 times 1 is 2. So I end up with 9 over 2 as my solution. And in terms of like reducing that down, 2 goes into 9 4 times with 1 left over. So the length would be 4 1/2 is my length there. Okay. Now, if the tiles are 3/4 inch by 9/16 of an inch, how many would Noah need to cover the tray completely without gaps or overlaps? All right, so here's the idea. We have our picture here. I'm going to draw a little one here. Oh, this is just a sketch. It's not the real one. It's only a model. So we have 11 1/4 on the length, and we know that the height here is 4 1/2. And the question is, if the tiles are 3/4 inch by 9/16 inch, how many would they need to cover that whole space without gaps and overlaps? Explain or show your reasoning. Okay, now this is where it doesn't matter which way you want to put it. We're going to put a tile, let's pretend, like our other one on the graph paper, we're going to put a tile right here. Don't worry about the size. The size is not that important right now, okay? Okay, and I can decide which one's going to be my 3/4 and my 9/16. If you decide to do the other way around, that's okay. What I mean by the other way around is this. If I want to say that this is my 3/4 side here, and this is my 9/16 side there, that's great. If I want to turn it the other direction, I would have different equations I'm going to work with going forward, but I'll end up at the same spot. It really doesn't matter, okay? Because the numbers giving us, we're going to be okay. So I want to say that this side length is the 3/4 side, and this is the 9/16. So the question is, how many of these 3/4 am I going to get in a space that's 4 1/2? And then how many 9/16 are going to be in a space that's 11 1/4? It's a little bit like your book binding problems from the library, right? How many can fit? You have a shelf that's this long, a book is this wide. How many of the books can you get on the shelf? That's the idea. We know that this length is 11 1/4. So how many 9/16 can we get on that shelf there? We know this is 4 1/2. So how many 3/4 can we get over here? That's what we're trying to figure out. And to do that, we're looking at how many groups of 9/16 are going to be in 11 1/4, and then how many groups of 3/4 are going to be in 4 1/2. So we have two different division equations. Let's go ahead and start with the first one, top one up here. This is, my length is 11 1/4, and I want to know how many groups of 9/16 would fit across that length there. So let's rewrite this as an improper fraction. So 4 times 11 is 44, plus 1 is 45. So we have 45 over 4, and that's divided by 9/16. We're not going to do division, we're going to multiply by the reciprocal. So 45 over 4 times 16 over 9. And we have nice numbers to reduce with. Whoops, gotta move around the room. Hold on, there we go. Motion sensor lights. I've been standing still too long. Sorry about that. So we have 1 4 here, and we have 4 4s there. I know 9 goes into 45 5 times, so we have 1 9 and 5 there, 5 9s there. And 5 times 4 is 20. So this tells me I can get 20 of these all the way across. So I can get 20 there, going across that way. Now for this part here, we have 4 1/2 divided by 3/4. And this becomes 9 over 2 divided by 3/4. And we multiply by the reciprocal, 4 over 3. We reduce, and 3 times 2 is 6. So I get 6 over here. So I'm going to have 6 tiles going down and 20 tiles going across. The question though is, how many would he need to cover the tray completely? Well, I have 20 here, and I have 6 rows of 20. So think of it that way. I have 1, 2, 3, 4, 5, 6 rows of 20. Right? And we can do it by going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 17, 18, 19, let's make one right here, 20. Pretend those are all the same and the correct lengths. Okay? And we don't have to count all those up. I'm not interested in counting those, are you? I'm not. That's how do we do it? We do 20 times 6, and it tells me there are 120 tiles. Way to go. So that's what he would need. Draw a diagram to show how Noah could lay the tiles. Your diagram should show how many tiles we needed to cover the length and width of the tray, but does not need to show every tile. Oh, well hey, guess what? We just did that right there. So if you want to draw it a little nicer, you certainly could. Right? And that's the idea. So if I was to do this nice in a nicer way, what I'd probably do is I'd draw a line here. And I would go a line here. And again, I'd show my 6. I'd say 1, 2, 3, 4, 5, and one more makes 6. To show these are my 3/4, right? All the way down for a total of 4 1/2. And then I would draw lines here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And this is a horrific drawing. This is why we use graph paper, right? And this is 9/16 here, all the way across. And that whole thing would have a length of 11 1/4. It didn't say you had to draw every tile, right? We could have just done the top row and the side row there and been okay and left that blank. So however you want to do it, that is the idea. All right, so in summary today, for today's fantastic lesson, if a rectangle has a side length A units and B units, the area is A times B square units. Got it? For example, if you have a rectangle with a 1/2 and a 1/2 inch sides, then the area is a 1/2 times a 1/2, which is 1/4, right? Which is 1/4 of the whole square. So that means if we know the area of one side of a rectangle, we can divide to find the other side. So like we did before, if we know the area, we can use division to figure out what's missing, right? Because area is going to equal a side times a side. And so if we know that one is 89 1/4, and it's equal to something I don't know times something I do know, that becomes a division problem, like so. And we can solve for what we don't know. which is exactly what it's saying right down there. Okay, so we're going to pause there, and you're going to do your homework, and we'll come back and check that together in just a moment. All right, here we go. Homework for grade 6, unit 4, lesson 13. Find the unknown side length of the rectangle if its area is 11 meters squared. Show your reasoning. All right, so this is what we left off with. The idea was that I can do this because I know that the area is equal to a length times a width, and if I know two of those parts, I can get this resolved, right? So in this case here, I don't know what the length is. I know that the width might be 3 2/3, and we know that it has an area that's equal to 11. We've seen it many times before. And I can then turn this into a division problem by doing 11 divided by 3 2/3 in order to solve that out there. Whoa, I'm way off the paper. My goodness. So sorry about that. All right, so this becomes 11 divided by 3 times 3 is 9 times 2 is plus 2 is 11. So 11 over 3. We'll make that by multiply by the reciprocal. That's 11 over 1. So the 11's cancel, and you're left with just 3. So what is our side length? Our side length is 3. So just check your answer by multiplying it by the given side length and see if you get 11. So it's saying, well, let's try it. Will we do 3 times 3 2/3? Do we get 11? Well, 3 2/3 is the same as we said before, 11/3. So this is really 3 times 11 over 3, right? Because 11/3. So as an area, length times width, cancel, cancel. What are you left with? Just 11. Does that match? It sure does. We're okay. Cool. I'm looking at number 2. A worker is tiling the floor of a rectangular room that is 12 feet by 15 feet. The tiles are squares with 1 1/3 feet. How many tiles are needed to cover the entire floor? So what we're asking here is we're saying if I have a room that's 12 by 15, I'm going to put a square tile in here that happens to be 1 1/3 on both sides. How many 1 1/3 are inside of 15, and how many 1 1/3 are inside of 12? So I'm going to do two different division problems. I will do 15 divided by 1 1/3. I'll also do 12 divided by 1 1/3. That's going to tell me how many tiles across and down. And to do the entire floor, I'll need to multiply those answers together to find how many. So this is 3 4/3, so I have 15 divided by 4/3. And over here I have 12 divided by 4/3. Let's do this one first. This becomes 15 times the reciprocal, 3 over 4, which is 45 over 4. And over here, which, can I leave like that? Sure. I'll leave it like this for now. Okay, so 45 over 4, which is the same as, I'll reduce this, becomes 11 1/4 there. Over here, we're going to multiply by the reciprocal, and we get 12 times 3/4, which is going to be reduced to 1 3. We end up with 9. So I know that I'm going to need 11 1/4 to go across this way, and I need 9 to go this way. So again, looking like this, I need 11 1/4 tile to go that way and 9 tiles to go this way. Not worry about the size, that's just how many I would need. Okay. Now, if I need more than 1/4 tile, I'm going to definitely need more than than 11. So if I thought about being 11 times 9, that's not going to quite work out too well, right? Because I'm going to need more than that. So I think of it more like I'm going to need at least 12. I'm going to cut the tiles there to cover the whole thing. So 12 times 9 is going to be 18, carry the 1. We have 108. So 108 could be an answer you would use, right? It could be an answer you would use. This is a could be kind of thing because realistically, I can do 11 1/4 times 9, right? And 11 1/4, we said before, is 45 over 4. When I multiply that by 9, I end up with 405 over 4, which can be reduced, lovely enough, into 101 1/4, or about 102 tiles. So either one would work. Realistically, 102 tiles is exactly what you would need. You'd end up with 3/4 of a tile left over if you cut them in half. If you just wanted to go and cover it and extend over the room and just cut them all off, you do this. This would save you money because every tile costs money, right? Here I'm buying 6 less than that one, so it'd be better to use this equation. So that's why it'd be better to do some math, because I wouldn't have to buy 6 extra tiles. So that's a better solution. So this is probably the solution your teacher's looking for. That one would work as well, but you would be paying more money for more tiles. Number 3, television has a length of 16.5 inches, a width W, and an area 462. So what do we know? We know we have a length 16.5 times a W for an area of 462. So we know that's to be the case. We also know that we can turn these equations into division problems by doing 462 divided by 16.5 equals W. Let's see what we can find over here. Here's a width times an area. A width times an area? I don't think so. Here is a length times a width gives us an area. I like it. Here is an area divided by one of the lengths gives us the width. I like that one too. Here is the area divided by a width gives us the length. That works, right? Because that's okay. We can go either one. This could also be 462 divided by W equals 16.5. That's just fine. And then we have 16.5 times an area gives us the width. It does not. That's not going to work. So we're going to go with B, C, and D for number 3. Number 4. The area of a rectangle is 17.5 and its shorter side is 3.5 inches. Draw a diagram that shows this information. Okay. We have a rectangle. All right. And we know this is 3.5 inches and the area is 17 inches squared, and we don't know that side. Right? So this rectangle has an area, has a side length, and something we don't know. Is that a great drawing? Nope, because I'm looking right now, it says the short side is that one and that one looks longer. Is it the end of the world? Nope, not the end of the world. So, oh well, that's okay. To make it longer, here, there you go. Now it's longer. Is it better? Is it better? Yay! Okay, so there we go. Now it looks and it matches great. So what's the length? Now let's solve that one there. Oops. We're going to do 17 divided by 3.5. So, 17.5, sorry. I messed up my drawing. Oh no, that's why my drawing is bad. Because my handwriting is bad. Haha. So 17.5. It's just got worse and worse. This is why you don't do your homework at 6 in the morning. Okay, so here we go. We're going to go 17 times 2 is 34, plus 1 is 35 over 2. And this becomes 6 and 1 is 7 over 2. We're going to multiply by the reciprocal, so 35 over 2 becomes multiplied by 2 over 7. The 2's are going to cancel out, and 7 goes in here 5 times. So our length is 5. All that to say 5. Cool. All right, number 5. A bookshelf is 42 inches long. How many books of a length 1.5 inches will fit on the bookshelf? All right, we talked about this in our lesson today a little bit, right? There's our long bookshelf. We want to know how many groups of 1.5 are inside of that. So your bookshelf looks like this, and how many 1.5 little books can fit all the way down there. All right? So what are we doing? We're doing 42, and we are dividing it by 1.5. 1.5 is the same as 3 over 2, so it's 42 divided by 3 over 2. But we multiply by the reciprocal, so we have 42 times 2 over 3. And 3 goes into 42 actually 14 times. How do you like that? And 14 times 2 is 28. So we get 28 on one bookshelf. A bookcase has 5 of those bookshelves. How many feet of shelf space is there? And explain your reasoning. Okay, how many feet of shelf space is there? This is the key. It doesn't want to know how many books you can get on 5. If I want to know how many books I can get on 5, I would do 5 times 28. But we're talking about the shelf space. The shelf space is 42 inches long, and there are 5 of those. So I end up with 210 inches of shelf space. Okay? If I want to know how many books I can get on there, then I would do something a little different, wouldn't I? Okay? So that's inches there. If you want to know in terms of how many feet, oh, it says feet there, yeah, feet. So I have 210 inches. To do feet, I need to do 210. I need to divide that by 12 because there are 12 inches in a foot. Okay, so 210 divided by 12 is equal to 17.5 feet of space there. Okay, cool. Number 6, find the value of that. Show your reasoning. Sure. So we're going to do 5 and 32 multiplied by the reciprocal, which is 4 over 25. 4 goes into 32 8 times. 5 goes into 25 5 times. 1 times 1 is 1. 8 times 5 is 40. And we're done. Number 7. How many groups of 1 and 2/3 are in each of the following quantities? So we're doing 1 and 5/6 divided by 1 and 2/3. Well, 1 and 2/3 is 3. Well, I'll write down here 1 and 2/3. 4 and 1/3 divided by 1 and 2/3. And 5/6 divided by 1 and 2/3. All right, so this is 6 times 1 is 6, plus 1 is 11. So we have 11, 6 divided by 1 and 2/3. Now, what is 1 and 2/3? Let's rewrite this one real quick before I move forward. It's 3 plus 2 is 5, so we have 5/3. So we're going to multiply by the reciprocal, 3/5. We reduce here, reduce there, and we end up with 11 over 10. For this one, 3 times 4 is 12, plus 1 is 13, so we have 13 over 3, divided by same 5/3. We're going to multiply by the reciprocal, so there's 3/5. The 3's cancel out, and we have 13 over 5. And finally, we have 5/6 divided by 5/3. We're going to multiply by the reciprocal, and the 5's cancel out, and we end up with 1 and a 2. So we end up with a half right there. And our last problem for the day. It takes 1 1/4 minutes to fill a 3-gallon bucket with water with a hose. At this rate, how long does it take to fill a 50-gallon tub? 50-gallon tub. Oh my goodness. So we know it takes it says use a table if you get stuck. It takes 1 1/4 minutes to go 3 gallons, and we want to go to 50. So let's think about this. I can make a table where I do minutes and I do gallons, like so. And what I know is it takes me 1 1/4 minutes to do 3 gallons. Okay? So a couple things I could do. It depends on how you want to get there. I want to get to 50 is my goal. I want to get from 3 to 50. So the way I did it is I went, well, let's turn gallons into 1. So I'm going to divide by 3 to get to 1 here. So if I do 1 1/4 divided by 3, this is 4, 5, so it's 5/4 divided by 3, which is 3 over 1, which is 5/4 times reciprocal, 1/3, so I get 5/12. Now that's not a great number, but I'm going to go ahead and put it in there for 5/12 right there, because this is 1/4 divided by 3. Now, to go to 50, I'm going to multiply by 50, multiply by 50. So we're going to do 5/12 times 50. Can I reduce first? I could, right? So 2 goes in here 6 times, 2 goes in here 25 times. I don't know if that reduces anymore, really, right? 25 and 6, not really. So we have 5 times 25, which is 125 over 6. 125 over 6, okay, is what I have so far. So I know it's 125 over 6 minutes. Could we make that like a little nicer? Can we see how many minutes that's going to be? Right, this is 50. I could do 6 and go into 125. It goes in there 2 times, 0, and it goes in there 0. So we're going to be a little more than 20 minutes plus something or other. So 6, 7, 8. So let's just go about 20 and 8. So 20 with some left over. So we're going to go 20 and 5/6 of a minute. All right, so just about 21 minutes is what it's going to be. So you can leave it as a fraction, or you can do a mixed number, something like that. That's it for today. Have a great day, and we will see you next time.